Welcome back, guys, to another Band and Tech video. Today we're going to be taking a look at an old Ethernet hub. Now, this Ethernet hub is relatively simple in design, and you'll notice a couple of similar features to the switches of today. Now, there are two differences between Ethernet hubs and Ethernet switches. Now, Ethernet hubs, a lot of people like to refer to them as hollow, ugly boxes, and that's because they literally do nothing but just split the traffic into multiple ports and spam all the other ports with one person's packets. Now, Ethernet switches work a little bit differently in that they route the specific packets to a certain host, and you can have that up to a lot more sophistication with managed switches. But in this case, we're looking at an Ethernet hub today, so we're going to disregard all the other switches because we don't care about them. Now, this Ethernet hub here is relatively old. This is likely from the 90s, late 90s, early 90s, one of the two. I can't find an exact manufacturing date on this device or online for whatever reason, and I'm not sure if the company is still in business today. But we're going to take a look at some of the features on this thing. Now, there are a lot of cosmetic issues with the device. It's been used. It hasn't been just sitting somewhere not being used. This thing has probably been used half its life. You'll notice right at the bat there's 16 ports on it, and you can daisy chain off of hubs, which I'm not sure about how that works, but I assume that if you have it flipped here, it's a crossover cable, and if you have it flipped here, it's just parallel, one of the two. But either, I know on the older devices, it's either port 16 for that function or port 1. On the back, you'll notice that there are couple more things, interesting things on here. Of course, we've got our power. This can take 50 or 60 hertz depending on what country you're in, what wherever you are in the world. 120 to 240 again. And then there's a standard PC plug port. There's an off-on switch, and we've got a BNC connector, which actually is used by a lot of older networking equipment. These are very obsolete nowadays. They are like super slow when using them, and it's called a token ring network. They require a T like this with two terminators on each end so that the device doesn't panic or short out or whatever. But I do know a little bit more about this AUI port. Now, this AUI port is pretty interesting in that it's like today's SFP port in a way. Now, the two are completely different, but you'll notice that there's a couple of different features with this AUI port. And one of them being it's 15 pins and it has a locking mechanism on it. And you're kind of thinking, well, what the hell plugs into there? Like what do I put in this thing? Well, good thing you asked that question, because I actually have a device here that is an AUI device. It's called an Ethernet transceiver. Now this is made by a company called Black Box, and Black Box is actually a local company to me, but yeah, it's a mini 10 base T transceiver, meaning it does 10 megabits per second. You'll take a look on the back here. You'll notice this device, it complies with the Part 15 of the FCC rules. Every device in America or beyond has to abide by that law. Now, you'll notice this device does 10 to 15 volts and is 120 milliamps. Now, Ethernet standardly operates at like 1.5 volts, so this is kind of higher, but it would make sense since this device can, just transform that voltage down or whatever. Now, if you notice the label down here, it says made in ROC, and I believe that means Republic of China. It's just another fancy way of saying China, I guess. And then we have, the lights. There's like 6 different lights on there, and then an Ethernet port which has a couple of different switches on it. Now, each of these switches do something different. First, we have the SQE switch way on the right, and that's for the signal quality errors. It allows for signal quality to be increased, sending a heartbeat signal over one of these pins on here. It allows for this device to essentially operate without errors. However, you'll notice on the equipment that we are going to be using this transceiver on, it says external transceiver without SQE test. So essentially what that means is this dip switch needs to be turned off in order to use this with this device. Otherwise, you'll have a very slow operating device. and you'll have a very slow operating switch. So any packets being transferred over this device will cause the network to significantly slow down, and it won't work as well because you're going to be having a collision with the heartbeat signal, and yeah, it'll just cause a lot of issues. We just don't want to mess with that. So yeah, this is how it came OEM. By default, those are the switches that should be switched. So SQE is off, Link is on, and LRT is off. So the next we have is Link, and that just is saying, oh, you want to pass through this device to link it to that device, for instance. So that's pretty much all Link does. And then LRT stands for low receipt threshold. And now low receipt threshold allows this device to essentially, when that switch is in the on position, and it allows this device to go farther than 100 meters, which is actually the maximum length of an Ethernet cable. I don't know how this device does that. I think it puts more voltage through the Ethernet cable, but you probably would want to have another one of these on the other side of the cable, so that you don't fry any of your devices. So I would recommend not turning that on, because you could fry something. Okay, so now we're going to power this old device on, and the first thing we're going to do is we're going to grab a cable, a sufficient cable to connect. Whoops. The first thing we're going to do is grab a sufficient cable to power our switch on. And I have a standard 120 volt, like 10 amp plug to plug this into. You'll see it says 10 amps on the device. And that's just going to go into the 3-pronged plug here. And then we'll take the other one, the other end of it, which is a standard US cable, and plug it into, we'll plug it into the thing over there. Now I'm going to flip this around so that you can see the device. And it's going to go through tests. And there you go. So now this device is on. And now you're probably wondering, well, what do we do next? Well, now that I have this device on, we can go just plug this in because I want to see how it works. So first I'm going to just turn the power off, because with older devices, not everything is plug and play. We're going to plug in the transceiver to the AUI port. Now, here's some directions on how to do that. You'll notice that the AUI port has a locking mechanism on it, and that is pretty important when you're trying to lock the module onto it. All right, so what we're going to do is we'll see this locking mechanism here. Now we're going to have that slid all the way to the left, because what this is going to allow us to do, you'll notice there's two like notches on this transceiver, and that allows us to essentially put this device connected on here. It'll fit in those pins nicely. And then we can go ahead and flip this to the left or to the right with our fingernail, or you could use a screwdriver. And now that device is locked in there pretty tightly. Although if you pull it too hard, it will come out, because it's old and it doesn't want to work. But it won't come out with normal force. You kind of get the idea. And now, since you've kind of seen how the device boots up already, I'm just going to flip the power switch again, and we're going to see this device back here light up. All right, so now we're all powered up. We'll notice there's a POL light on the transceiver. Let me pull this a little closer. There's a POL light, which essentially means the polarity is correct with the device. If it was not lit, then that means that we would have to use a device to switch the polarity of the power pins. But we'll notice there's the link light's not lit, the collision light's not lit. Collisions with the TX and RX packets on the TX RX light are not lit. So now we're going to before we do anything else, plug in Ethernet cables to the front of this device so that we can test the Ethernet capabilities of it. And we're going to compare speed tests between both using the hub and not using the hub to see which one is faster and which one is slower. Yeah, let's do it. So now we're going to do a network test between the hub and without using a hub to see how this device handles. Back in the day, you know, there wasn't that much stuff that was going through these switches, likely, you know, small application data. Nowadays, we have lots of web traffic, and if we're watching YouTube videos or whatever, it's going to be transferring a lot more packets than you would expect. Now, to test this, I'm going to use a couple of different methods. First, I have a voice over IP phone. I have a voice over IP phone, and this is a Grandstream GXP2130. And this is a Ethernet connected phone, so it has the Ethernet cable. We're just going to plug that into the switch once we connect the internet. I'm going to grab a random Ethernet cable from out of the corner of the room that's not suspicious at all, and just plug it into the hub on port 16. You can do whatever port you want. Just might not work for you. You'll notice the link light lights up there for port 16. And now we'll go ahead and just plug in our good old Ethernet for our phone. And I'll put this phone up here so you can see what's happening with it. I'll rearrange this. So this phone currently says no LAN cable. Now, thanks to the capabilities of my good old Samsung A03, we're going to plug in the... we can't see anything on the screen, or we can barely see this hub. And thanks to the crappy viewing angle and everything, it's screwed. All right, so you'll see this second link light up. And there we go. It took a couple of seconds to do that. But yeah, it's up and running now. We're going to make a short distance call with the phone. I'm just going to dial extension 200, which is the desk phone on my desk. Now I can kind of see that there's a little bit of load on this device. The first light lit up there is the load light. And now we're going to voicemail because I didn't pick up. But you can see that there's two things there: collisions and VTIL, which is the UTIL, which is the utilization of this device. Now I'm going to zoom back out because this camera can't focus. But you can see the utilization is actually 1% utilized. And then we have the collision number, or collision percent, which actually was lighting up because devices like these, you know, they're not meant for newer networking equipment. There's going to be a lot more collisions, packet collisions. That just means that it's not being routed significantly correctly or whatever. All right, so now we're going to... I'm going to keep a call going just to see what our utilization turns out to be. We're back at 0% utilization. Let's go ahead and... So that's great. I'm going to have to figure out why that broke. But I'm going to call... I hate Grandstream's ringtones, but you gotta do what you gotta do. I'll put this on speakerphone. Put it on hold. Copyright, 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 copyright. And I just... Okay, to avoid copyright issues, I'm going to take it off the hook. 1% utilization. Now, let's see what happens. Oh, we got some collisions. Let's see what happens, though, when we plug in... a newer computer. Let's do that. I'm going to start a YouTube stream. Actually, we'll do Twitch, because Twitch is a lot worse. Taking this cable, putting it in. Holy crap. So now we're probably completely, fully utilized now with a common, gaming computer. And our collisions are 100%. It's 15 plus collisions, excuse me, and 65 plus % utilization. You notice our light is blinking here. It's definitely not blinking. I mean, it kind of is constantly, but you can barely tell this one's blinking, but it is. But you can tell that where packets are going and stuff. Let's do a network speed test now to see how fast this device will work. We don't need the IP phone anymore, so I'm just going to move it out of the way. Sorry, I'm looking for something to use. Alright, so now we're going to do the network test. You can see that just a Google search kills it. Opening a web page kills it. Alright, let's do this test. Seven megabytes per second. 7 megabytes per second. And now our upload speed is about 8 megabytes per second. So this device is not lying when it comes to the capabilities of it. Not bad, not bad. Okay, now we're going to test with, now we're going to test by putting the internet cable. So that's this cable right here. We're going to put it on the AUI port and see what it does. So let's move that back. You can see the light has gone off. And let's plug it in. There we go. We have our link light and our X and TX are now lit. Alright, so now we see our AUI collision light and our utilization light. I'm going to now go ahead and start the network test again. Yep. We're still looking 7. Actually, our speed may have decreased just a little bit, but it's about the same as it was. Our upload speed is 8 megabytes per second. 8.7172 megabytes per second. Okay. Now we're going to test without it. So that means I'm just going to take the Ethernet and plug it back into the regular place where it goes. But that's still satisfying. All right, now we're going to go ahead and plug everything back to where it was and test the speed on that. I'm going to unplug this Ethernet from the back of our device. Whoops. And I'm going to unplug this Ethernet from the back of the AUI. And now we're going to test this again with our regular internet speed. Oh yeah, that's how it should be. That's how it should be. That's speed. I don't get why the upload speed's always quicker than the download speed. It doesn't make any sense to me. But you know, hey look, it works. That's why you should not use hubs anymore, because they're obsolete. No, I'm just kidding. Hubs are alright. They're fine for for older equipment, but I would not probably use them in any of my newer stuff. And that's why we're on to our sponsor. A big thank you to the sponsor of our channel. Okay, what is this? What is it? What is this? I didn't know we had a sponsor. Wait. No way! Is this what I think it is? A 48 port Ethernet switch with all included supplies, including open source firmware and all of its glory. That's right, guys. So I just got a 48 port Ethernet switch. This is an enterprise switch. It's a Juniper something or other. Give me a second. It's a Juniper Networks switch. This is the EX3200 series with 8 PoE ports. You could call it obsolete if you want, but it works fine for me. And this here allows me to put SFP ports on it. So I'm going to be putting an SFP module in there. That'll probably be a later video. But yeah, this is what I'm going to be installing later in another video at some point. But yeah, got this from a friend for relatively cheap. That's where I get all my shit from. But yeah, I mean, this is the difference between our new office and our old office stuff. So I used to use this hub for my older. I ran a Windows 2008 server on an old laptop, and I use this hub for most of the communications between the clients and the domain controller. So yeah, I mean, this device can be used in my 90s office, which new videos are going to be coming out soon on that one. But yeah, I mean, that's pretty much it for this video. It's pretty much going to do it for me from this video, guys. I hope you enjoyed this. If you want to like and subscribe, that's greatly appreciated. Leave your comments in the comment section below. I'd be happy to answer any questions or concerns about the video. Quality is coming up. I promise you, quality is coming up. I can't afford a camera. Please help me! Alright, well, camera's being a dickhead. I really have no idea what I'm saying right now. Fuck me. To ever have a video that actually works for once. Anyways. Why am I showing you my notes? That goes... no. Fuck me, damn it! Jesus. I can't believe I have to do this. Again, thanks to my crappy phone. It's just the exposure is really crummy on it. Whatever.